Okay, this is notes for myself on how to build a simple RAG system using LangChain, Ollama models, and Qdrant vector databases. So I have already in my requirements text defined the modules I need for this. And this basically also requires for having the Docker set up for Qdrant and how to make it point to my drive D to store all my containers. And then this is also to set up my Python environment using the Python with the -m all right, so let's go ahead and look at my data. In this case, I've just created a simple CSV file with a bunch of my friends' name and their ID numbers. I just numbered them. And then also gives me a little fact about them. That's all I have. So the whole idea of this exercise is this data could be a CSV file, Excel, SQL, it doesn't matter. Basically, if you have your own data, how do you chat with it? That's really the whole intention. And I've done this using this as simple as I possibly can to set this up. So what I'll do is we're going to go ahead and let me just start with the project. So I'm going to create a file called main.python. I'm going to build this step by step the way I think, and I move on. So the first thing I need to do is set up my LLM to point to the Ollama for my chat purposes. And I'm going to use LangChain, so I need to use the Ollama that comes with the LangChain. So there we go. And I'm going to import the chat Ollama. So I'm going to set my LLM to use the model Qwen 3-coder. That's the one I actually like. And I'm going to say the base URL runs at localhost. And by default, it runs at port 11434. Now, I can always, if I don't remember the name, I can do Ollama list. This is a good test that if you get this result, means Ollama is running in the background and gives me all my models. Later on, a little bit towards this, here, this is the one I'm using. I don't need to put latest. And I'm going to be using this later on in this video for my embeddings. Okay, so here I have my LLM defined. Let's go ahead and create my loop. That's the way I like to think. All right, so I'm going to receive what the user wants the question to be. So question is equal to the user enter your question. Q to quit. All right, so now I'm going to test when I should quit. If question is equal to quit, then break out of the loop. All right, so that's what I have. So now here's what I have. I have my LLM, I have my main loop. Now I need to tell the LLM what is it that I want it to do. I do that using my prompt, but to build my prompt, I'm going to use the chat prompt template so I can build a dynamic variable replacement along the way. So for that, I need to go ahead and set the from LangChain core.prompts prompt import the chat prompt template. There we go. So here for my template, I have the following. I'm going to tell the LLM what I want it to do. You are an expert in answering questions related to my data on facts from my friends. Let's see if it makes sense to it. Your answer will be short and precise. You will not explain or reason as to how you got the answer. All right, so that's my clear instruction. And I'm going to say here is the data. I'm going to pass it in, and then here is the question. Good. So that's my template. Now let's build the prompt. So prompt is going to say from the chat prompt template, from template. Okay, so this is my prompt, but now what I need to do is when I call my LLM, I need to create a pipeline. The first thing I need to do with this pipeline is somehow give it the data, give it a question, and once I know these two things, send it to an LLM. So the way I do that is use a chain command or a variable to define my chain process. I'm going to say start with prompt. So when I invoke it, prompt comes first where I want those two variables, and I'm going to use this as my pipeline. Once I have that, call the LLM with it. All right, that's basically it. So I go down here now. Initially for my, right now, just to get this going, I'm going to say my data has nothing in it. So I don't have to worry about reading the CSVs and do all that. Let's get this piece working. So data has nothing in it. So now I'm going to do a for chunk in chain.stream. I'm going to get tokens one at a time to process, so I don't have to wait for the whole answer. I could have used chain.invoke, but I want to use the stream. And now when I want to call my LLM, I need to give it two things: data and the question. And that's it. So the data currently is blank, and the question will be whatever the user says. So then I'm going to go print it. I'm going to print chunks. Every time you print statement in Python, it skips a line. Since it comes token at a time, I want to say don't skip a blank line so that it doesn't do that \n. And then I'm going to say flush is equal to true. All right. That's pretty much it. I'm done with my main structure. Let's go test it. Python main.py. Who lives in Toronto? What did I do wrong? HTTP, I can already see my misspelling right there. And then also while I'm at it, I want to put a little print statement here to separate my questions. All right. So I go down here. Who lives in Toronto? All right, it gave me a whole slew of stuff, as you can see, other properties. That's from a result of chat Ollama from the LangChain. It tells us things like if you're using tool calls, number of tokens sent, and all of that. I'm not interested in that. All I want is get the content right here. This is what I want, content. So dump that out for me, content. Whoops, there we go. So let's clear the screen. Who lives in Toronto? All right, so look, it already went in. I can't answer it, so our first part is good. So now I want to go ahead and set up my Qdrant, take this data, build my Qdrant file, and then basically for this data, I wanted to get the result set based on the question. So let's put this aside. I'm going to go ahead and create another file called Qdrant vector.python. All right. So in here, in this module, my intention is to take care of how to create the tables or the vectors, and then how to do the retrieval for the relevant documents. So first things first, I need to go ahead and use the Qdrant client to basically say where it's stored, how to talk to it. and I'm going to say that's the Qdrant client, and I'm going to also need to use the models and pass in the vector params, which I'll tell you that in a minute. I need to say that I'm going to use the distance, and I'm going to, for insertion, I'm going to use the point struct. There we go. So I should be good with that. Now for the LLM embeddings, I'm going to use the same thing as I last time, LangChain, Ollama, but this time I want embeddings, and I'm going to say import Ollama embeddings. So let's go ahead and define my embeddings function. Embedding is equal to Ollama embeddings. Model, as we call earlier, I mentioned about the model I'm going to use here is going to be mxbai-embed-large. And I'm going to say my base URL is equal to HTTP localhost 11.434. That's where the Ollama is running. So I have my embeddings. Now I need to define a client where my Qdrant is. Qdrant in this case is using the Docker. So my client, for the way I do it is I'm going to say for Qdrant client, I'm going to say the host is localhost. Whoops, did one jump down there. Localhost, and then the port is equal to, that's a default port when you run the Qdrant that it will run at. So I'm going to just go ahead and say this is the Qdrant, Docker. And this basically was in my notes file here. You see, that's where I'm running Docker, the port, and it's going to store it in my drive D. All right, so that's so I have the embeddings. I know where the Qdrant is. Now I'm going to say, what do I want my collection name to be? Collection name, I wanted to call it friends. And then I want to go ahead and say my file name that I'm going to process later for the data is going to be data.csv. All right, so I created some of my global variables here. Now what I want to do is I want to organize this code. I want to create two functions. One to just build the structure and the data, populate the Qdrant vector database. And the second one is to act as the retriever. So when I give it a search, it basically goes ahead and embeds it and returns the semantic search. It returns basically relevant data based on that. So let's go ahead and first create the vector database. So I'm going to create a function called create vector db. In here, I'm going to go ahead and first things first, see if the collection name exists. So I'm going to say if client.collection name exists of collection. If it exists, I want to delete it. So client.collection, delete collection name. So I just deleted it for test purposes. So every time I run, I want to rebuild it. Once I do it, then I'm going to go ahead and create it again. So client dot create collection. I have to pass a couple of stuff here. So collection name is equal to collection. And now my vector config here is where I need to bring in the vector params I defined above. And this is what this does. So every time I build this, so whether or not I give it one word, one letter, one page, I don't know, a bunch of paragraphs, whatever it is, the content of my text is, I need to tell it how many floating numbers do I want to represent the meaning of what I just typed in. So in this particular case, I say size is equal 1024. So no matter what input it receives, is going to return 1024 floating numbers to represent a meaning of that. And then I'm going to use the cosine similarity, so to basically whatever is it's closer points to each other in the space means the data is relevant to one another. So the distance, I'm going to use the distance is equal to distance dot cosine. I'm going to use that technique for it. So I created a collection, and now I'm ready to basically start populating it. So at first I need to read it. So from pandas, I need to go ahead and import pandas as PD. All right, so my data frame is equal to pd.read csv of file name, which I defined earlier. So now here I'm going to go loop through it. For I row in PD, not PD, df data frame dot, I'm going to iter rows. So just recapping here, my columns are ID, name, and fact. Okay. So the content that I'm going to store and create embedding for is going to be row sub name, which is the name of my friend, plus the fact about my friend. All right. Now that piece needs to be embedded. So it's going to basically get 1024 floating numbers. So I'm going to say content embedding is going to, I'm going to use the embedding model that I defined above, dot embed query content. So whatever I put in here is going to embed it for me, and that's what it did. Now I'm ready to insert it to my Qdrant. So client.upsert, it basically wants to know the collection name. Collection name is collection, and points needs to receive a list, and the point struct to basically struct that point in space. I need three things. One, ID needs to be the ID. I'm just going to number it so it doesn't start from 0. And the vector is basically the embeddings. So the vector here is going to be content.embedding. And then for the actual payload, I could just basically create any dictionary key value pair, but because I'm using LangChain, you have to make sure that it's called page content. That's what it's looking for. When you tie this to LangChain, it wants the payload to have the key value, key of page content. For page content, I want to put the content. And I'm just going to create something I'm not even going to use for here, but just to note for myself, is later on, if I want to add other stuff, it has to be called metadata. And then just for test purposes, I'm going to say source colon, I'm going to store just the file name, where it came from. That's all. So pretty much, and then I have, this doesn't look right, collection name, there we go. So I think I'm good with that. Let's go ahead and put a couple of print statements here. So print, I'm going to say creating Qdrant vector db collection, and I'm going to say collection name. There we go. So that's going to go ahead and do that. Oh, I missed the name here too either. Then I want to go ahead and print each time the rows that it creates so that I can see something is happening. Print content. Okay. And I'm just going to go ahead and separate this. All right. So I've created this that builds the vector database. Now I need to deal with the retriever. How do I retrieve it? So I'm going to say define get relevant. I want to basically get relevant data, relevant. All right. For that, I need to create a LangChain needs to know where to get this relevant data from. So LangChain, you need to go ahead and do the following. From LangChain and Qdrant, where the Qdrant database table is, going to call it as Qdrant, no, as vector lang. There it is, Qdrant vector store. That's the piece I wanted to look at. So I go in here and I'm going to say vector database or DB is equal to Qdrant vector store. I need to say where is it, and that is where's the client. The client is the client. That says it comes from the where we defined it for the from the Docker. That's where it's running. Client. What the name of the collection is. Collection name is collection name. And then what embedding to use. Embedding is equal to embeddings. So let me explain this piece here. So when I call this get relevant, I'm going to pass in a question, right? What I'm searching for. Well, that question needs to be converted to an embedding. And here it says use the embeddings, the same embeddings that we used when we created it. All right, once I'm done with that, I need to, return some relevant information based on what I found. So I'm going to say return my vector DB, or actually I'm going to call it vector store is better. Vector store as a retriever, basically passing relevant. It says search for is it search for search? I don't know, search. I think it's Q. I'll find that in a minute. Is equal to. I need to pass a JSON object that says pass in 3 relevant data. There might be something I need to figure. We'll find out. That needs to get fixed. Okay, I'm not worried about that just yet. So these 2 functions are done. Let me go ahead and create vector DB just for test purposes. I'm going to run this locally. Python vector Qdrant vector.py. So here it should create a collection and something went wrong. So it didn't like this ID part. Let's see why not. What did we do wrong here? Not ID, but I plus 1. That's the row number. All right, so I'm going to clear screen. All right, so it created it. It created each of those. And actually, I can go ahead and put this outside of the loop. I think I should be good with that. So that piece works. So let's go ahead and delete this. Let's go back to my main program. Let's make use of it. So from Qdrant vector, and I'm going to import the 2 functions I wrote, which is create vector DB and get the relevant data. All right. So here, before I go into my loop, I want to build it. So I'm going to say create vector DB. This should create my vector database. And for data, I'm going to say get relevant, invoke it, pass the question. Simple as that. So let's go ahead and see what happens now. I may have an error with that k arguments for a search. We'll find out. Okay, main.py. It built it. Enter your question. Who lives in Toronto? Oh, it worked. So Daisy lives in Toronto. Look at this. Let's see which of my friends loves rabbits, right? So which of my friend adores rabbit? Let's see what it answers. Vicky. Then let's do one more thing here. For Daisy, look at it. It says she lives in Toronto and her husband is Ken. Let's see if it can answer that question. Who is Daisy's husband? Ken. I think we should be good with that. But let me also show you where the Qdrant stuff is. So I'm going to say to localhost 633 dashboard. If you look, here's my friends. It has 5 points. Let's click on it. Look, the page content, and we've got the source. Yep, that's it.